Hey there. Hope everyone's hanging in there. Welcome to O-Level Physics. This is Lesson 9, Thermal Energy Transfer. Thermal energy moves spontaneously from a hotter region to a colder region until thermal equilibrium micrometers. The three transfer processes are conduction, convection, and infrared radiation. A real situation may involve all three, but an explanation should identify the dominant pathway and how a design changes it. Insulation slows transfer, it does not stop energy permanently or create coldness. Conduction transfers energy through particle interactions without bulk movement of material. At a hot end, particles vibrate more and pass energy to neighbors. Metals conduct especially well because mobile electrons carry energy rapidly through the lattice. Wood, plastic, and trapped air conduct poorly, making them useful insulators. A metal pan needs good conduction at its base but a low conductivity handle. Convection occurs only in fluids. Heating a fluid makes it expand, usually lowering its density. The warmer region rises while denser cooler fluid sinks, forming a convection current. In a room, a heater near the floor promotes circulation. Saying that heat rises is imprecise. Warmer, less dense fluid rises because of upthrust, while thermal radiation can travel in any direction. Radiation is transfer by electromagnetic infrared waves and requires no medium, so it carries energy through space from the sun. All objects emit and absorb infrared radiation. Hotter objects emit at a greater rate. Dull black surfaces are good absorbers and emitters, while shiny light surfaces are poor absorbers and emitters and good reflectors. Surface color does not control conduction through the material. A vacuum flask reduces all pathways. The vacuum between double walls prevents conduction and convection. Silvered surfaces reduce infrared transfer. An insulating stopper reduces conduction and prevents convection through the neck. Thin supporting points reduce conduction area. In a building, loft insulation traps air, cavity foam suppresses convection, double glazing traps a gas layer, and shiny foil reduces radiation. Experiments compare cooling by controlling volume, starting temperature, container shape, and surroundings. Record temperature at equal time intervals and plot temperature against time. A steeper downward gradient means faster cooling at that moment. Cooling slows as the temperature difference from surroundings falls. A fair comparison uses identical containers except for the tested surface or insulation and repeats measurements to judge random variation. For an insulation explanation, name each transfer mechanism, describe its physical pathway, and state exactly how the feature reduces it. In cooling graphs, compare gradients at the same temperature difference. Silvered vacuum flask walls reduce infrared emission and absorption, while the vacuum prevents conduction and convection. The stopper limits conduction and stops warm air circulation through the neck. Do not say heat rises in every situation, describe convection in solids, claim a vacuum blocks radiation, or attribute shiny surfaces to reduced conduction. Practice. Explain why a metal saucepan can have a plastic handle. Answer: metal conducts energy efficiently to food. Plastic is a poor conductor and reduces energy transfer to the hand. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Practice. Explain three features of a vacuum flask that reduce thermal transfer. Answer: vacuum stops conduction and convection, silvered walls reduce radiation, insulating stopper reduces neck conduction and convection. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. We'll leave it there for thermal energy transfer. Coming up next in O-Level Physics, continue the course. Take care, and I'll see you in the next one.